Video, we're going to figure out how to find missing angles and arcs when given diagrams involving central angles. For this example, they give you a central angle of 121 degrees, and they ask for the arc measure. Reminder, this is not the length of the arc, but simply the measure of the arc. In this case, in every case where they share the same endpoints, the central angle and the arc, the measures will be exactly the same. So whatever the central angle is, the arc measure will be the exact same thing. In this example, they give you the central angle is 87. That's going to mean that the arc measure is going to be 87 degrees as well. In this example, they ask for the measure of angle ECF. ECF is right there. So we're looking for that angle. Clues in the diagram. First, DF is a diameter going right through the center of the circle, therefore cutting it in half. So I know from D to F, the measure of that arc is 180 degrees. And that's because DF is a diameter. The other clue they give us is that these two arcs are exactly the same. There's only one arc each, meaning that these two angles are congruent. So we have some angle X and some angle X adding up to 180 degrees. That number is going to have to be 90 when you solve for it. So the angle at ECF is going to be 90 degrees. And this all hinges upon having this diameter here. The diameter did not go through the center of the circle. It would be a diameter, and you could not use 180 degrees here. In this example, they asked for the measure of MKI, that arc, the major arc, MKI. So that's all the way around here. MKI has 1, 2, 3, 4 pieces inside of it. And we just so happen to know all 4 pieces, 55, 67, 80, 72. Can write them inside. So to find the entire thing, you're going to add all the pieces together. So 55 plus 67 plus 80 plus 72 is going to be equal to 274 degrees. In this example, they ask you to solve for x. We have one arc measure that has x in it. We are given that this arc here is 135 degrees. This arc here is 86 degrees. Whenever I'm given more than one arc around the circle, I'm going to keep in mind that the entire circle is 360 degrees. Now, if I'm going to set up an equation using that fact, I need all the pieces here. So if this piece is 10x plus 5, vertical angles state that this is also going to be 10x plus 5. Likewise, if this is 135 degrees, that means that this piece is also 135 degrees. So I know that this piece here is given to you, 86, but since we know the entire larger piece made of these two smaller pieces, this number is a little bit more important because I can set up in the equation now, this 10x plus 5 plus 135 plus 10x plus 5 plus 135 is all going to add up to 360. So your equation should look like that. Or the other option is if this is a diameter and this piece is 10x plus 5 and this piece is 135 degrees, these two pieces should add up to 180 because the diameter cuts the circle in half. So right here, this piece will be half the circle. So the other option is 10x plus 5 plus 135 equals 180. In either case, this angle or arc measure is not going to help you any. Solving either one of these equations, you should get x is equal to 4. And since they just said solve for x, we're going to stop here. You don't have to plug anything into an angle. Look at another example. Number 16 in this case, we have x plus 67 for this arc. We have 75 degrees for this arc, and then 48 degrees for this arc. Again, right here, diameter, it's going to cut the circle in half, making this entire arc 180 degrees, the semicircle. These three pieces add up to 180. So x plus 67 plus 75 plus 48 equals 180. Because I know all three pieces, I can set up the equation just like that. Combining like terms, you would do 67 plus 75 plus 48 plus 190. Subtract 190 from both sides. X is going to be negative 10. You may be thinking, well, x being a negative number is an issue, right? Because you can't have negative angles. But it's not x that needs to be, that doesn't matter if it's negative or positive. It's the angle itself. So if we were to plug this back in, you get negative 10 plus 67. You would get 57, still a positive number here. And that'd be okay. Next example. In this example, they say find the measure of arc UV. That's the minor arc right here, U to V. And it is a minor arc because it's less than 180, and they give you the x plus 51 as the algebraic expression. So the first thing you do is find x, and then you can find that. So for finding x, we need an equation. If you'll notice that RU, this entire length here is a diameter, which means that from here to here, that arc is 180 degrees, which means that this piece, which we know as x plus 141, and this piece is x plus 51, should add up to 180. Making it 2x plus 192 equals 180. Solving a two-step equation, get 2x is negative 12. Dividing by 2, x is negative 6. Now the original problem says find the measure of arc UV, which we did find x first, but now we need to plug this back in for UV. Right here is UV. If you plug this number x in for this x here, .45 degrees is your measure. So a lot of these center around the diameter. Some of them center around 360. Just depends on the problem. Use the information given to you in the diagram. In all these problems, all the information you need will be in the diagram.